Welcome back, everyone, to the 2022 Moldex 3D webinar series. My name is Alex Baker from the Moldex 3D North America office here in Farmington Hills, Michigan. And today we're going to be taking a deep dive into sprue pressure and how we can resolve the pressure discrepancies between your simulation and the real molding process. Our agenda today is as follows. First of all, we're going to take a look at what is sprue pressure. So when we're looking at the sprue pressure curve in Moldex 3D, what are we actually looking at and how can we use that information? Then evaluating pressure discrepancies, what types of discrepancies exist, and where can we start to dissect Moldex 3D and figure out how we can fix those discrepancies, leading into our final topic, where we're going to look at a couple of other reasons why the discrepancies might exist, and so on. All right, so first of all, here starting off with what is sprue pressure. All right, sprue pressure is very simply just the pressure reading from the melt entrance. And that's a very important note, is that it's from the melt entrance. It's not from the hydraulic chamber or from a pressure sensor or anything like that. It's from the melt entrance that you specify in your model. The filling stage itself is a velocity controlled stage, and the pressure will need to increase to maintain that constant flow rate condition. All right, so during the filling stage, we have velocity control. During the pressure stage, during the packing stage, we have pressure control. So during the filling stage, we're going to be holding that flow rate constant, and we need to continually increase our pressure. That pressure is going to build as we move through the rest of our system. So everything after the melt entrance, therefore, is going to begin to cause a flow restriction, and that's where your pressure starts to increase gradually until eventually we get to the VP switch point, which we'll take a look at in a little bit. This restriction of flow will cause the pressure to gradually increase, as I was mentioning, and then only objects after the melt entrance will cause a pressure drop. I can't explain how important this is, because if you don't model a portion of your feed system, it's not going to be considered in the simulation. Therefore, the pressure drop through that object, whether it be the entire runner system like we have here, maybe the gate, the the nozzle, even the barrel, sometimes those regions of your feed system, if they're not considering it in the simulation, they are not going to be considered in the sprue pressure curve.